Okay, so in this first lesson here, we're going to take a look at sort of the basics for this course, the idea of data and what data is, how we can collect it, how we can organize it a little bit. And data really can be anything. It doesn't have to be numbers. Yes, we will use numbers most of the time because it makes our life a little bit easier to work with, to develop some new techniques for displaying and organizing our data. But data really could be anything. It could be a color, it could be a size, it could be a number, it could be a word, it could be a whole bunch of things. Okay? When we start talking about data, we first want to talk about what kinds of data there could be. In math, we sort of classify these into two types: qualitative data or quantitative data. Qualitative, a quality, is something that you look at. You don't measure, you don't count it, doesn't have a number attached to it. It's sort of like a category. Okay, so if we talk about, we're going to the parking lot, we're going to look at the cars in the parking lot. Well, what are some qualities that we can measure? Well, maybe the color, maybe the size, maybe the type, SUV or a truck or something like that. Those are all qualities. Okay? They'd be qualitative pieces of data. The opposite of that would be a quantitative piece of data. That's something you can measure numerically. We go back, look at those cars again. How much do they weigh? How many doors do they have? Okay, how tall are they? How many wheels do they have? Things like that. Things we can actually measure with a number. Within quantitative data, there's two types. There's discrete, things you can count, whole numbers. So, for example, how many doors they have. 1, 2, 3, 4, 5. You can count them right on your fingers. Or continuous pieces of data, things that you actually measure. They usually have units, sort of their giveaway. So I was measuring the weight of a car. It's 1,200 kilograms. Oh, kilograms is something I measured. Okay, that's continuous. Okay, so if we take a look at the first example here, we're just trying to classify these different types. Are they qualitative, quantitative, discrete, or continuous? So the hours spent watching TV. Now, if I'm thinking about hours, assuming that they're rounding off to the nearest whole hour or something like that, that's obviously a quantity. It's a number, quantitative. Okay? And if we're saying to the nearest number, we'd say that would be discrete. If we're allowed to have decimals and things like that within intervals, well, maybe that might be continuous. 1.6475 hours. Yeah, you've measured it in terms of hours. But to make it more obvious, we'll just say it's number of hours, discrete. Okay. Part B is slightly different. Time spent watching TV. Well, when we talk about time spent, does that mean like, oh, it's a lot of time? It's a little bit of time? Some time? Is it, are you measuring it in minutes and seconds and hours? Are you saying how many days of the week? This question is sort of really unfocused. This could be measured as a qualitative thing. I spend a lot of time. Or it could be a quantitative thing. I watch 6 hours a week. And within quantitative, maybe it is discrete. 6 hours a week. Or maybe it's something that you measured continuous. It maybe say, oh, it was, we measured in minutes. It was 47.2 minutes. So the question itself, the idea here, time spent watching TV, is very unclear, and you kind of really need to focus yourselves when you're thinking about, am I collecting data? How am I going to collect it? What am I going to do with this? Yeah, so just one of the ideas here is be careful. Brand of toothpaste, obviously that's a quality, right? Crest, something like that. Number of heads when 3 coins are tossed. Just flip them up in the air, you count how many heads. Count, oh, it's a quantity. And specifically, I'm counting, that's to be discrete. And the color in your bedroom. And so maybe that's blue, white, yellow, green, different colors, right? Those are qualities. Okay. Now, if the question was, how many colors do you have in your bedroom? That would be a quantitative thing, right? So again, this is sort of an unfocused thing. If I count the number of colors in my bedroom, well, then maybe I have 4, I have 3, I have 7. Well, that's discrete. And you can even sort of argue you can make this into a continuous thing if we're measuring things on the color spectrum. Right? We're talking about physics here. So you have to, again, be careful of how you phrase what you want to look at. Your height. Okay, we're back to, well, is it short, medium, tall? That's a quality. Is it you're 6 feet 3 inches? Oh, that's a quantity. So again, we have this idea where we have an unfocused kind of question. And if this one is a quantity, you'd probably be measuring this, right? So we consider that continuous. So we really have to focus on how we ask our questions, because changes the kind of answers we're going to work with. Okay. Let's say we've got ourselves a good question. Now we want to start working with it. Well, to make our data more manageable, we often want to organize it. The easiest way to organize something is making a frequency table. Sort of what we did in elementary school, a tally chart. Okay, so down the left-hand column would be your intervals or your types, depending on if you're working with qualitative or quantitative. Okay, you have little check marks along the middle there, your tallies, and at the end you have your frequency. Frequency is just a fancy word for saying how many. Okay. Sometimes you get these frequency tables that have so many different rows to them that you want to organize it. And we're allowed to reclassify things and group things together. We call those class intervals. So instead of having, oh, we went 0 to 1 and 1 to 2 and 2 to 3 and so on, maybe we just said, oh, I'm going to go 0 to 3. We reclassify things, makes our life a little bit easier to organize things. Okay. Once we have organized it, our objective then is to start displaying things. We want to sort of see patterns. It's easier to see patterns generally if they're in a picture form, in a graph of some kind. So just some reminders of some graphs we should know how to do. A column graph, or a bar graph as you guys probably call it. IB likes to call them column graphs just to mess with us a little bit. Okay, in these kind of graphs, the height of each bar represents a frequency, the number of each value or interval. So for example, we're looking at peas in a pod here. The big bar here, the most common one, there were 51 pods that had 6 peas in them. Okay. Or as you go to the 9, the least common thing, there may have been 1 pod that had 9 peas in it. And obviously there was no pods that only had 1 pea, and there's no bars over here, right? So we can see things much easier from this column graph than we could necessarily just raw data. A second one we can look at, frequency diagrams. This is a way of sort of classifying our data, classifying the shape of our data. So once we made that column graph, if we put a smooth curve over it, so just going back for a second here, if I were to draw a smooth curve over my data, it would look sort of like this. Okay, that's about the shape of the data. Okay. There are some common shapes that we can use to describe these things. And the most common one is something symmetrical, sort of a bell shape, if you will, in the first one. In large populations, lots of things come into bell shape. If we take a look at the heights of all the people in our school, it would kind of look like this. And most of our people would be in the middle. There'd be just a few really tall people over here, a few really short people over here. The majority of them are right in the middle. And the most common height would probably be the average height, right directly in the middle. But there's some other ones. We could have things that are positively skewed. The positive side has been stretched. So instead of being in the middle here, we've stretched the positive side and it moves it off to the left a little bit. Okay. Or we can have negatively skewed, like the last example, right? If we go back to this one over here, that's a sort of a negative skew. Most of my data is towards the right-hand side. I'm missing most of the left-hand side. It's been skewed in a negative way. Probably like marks in IB classes, right? Most of us are getting 80s and 90s, a few at the 100s, hardly any towards the lower end of that. Okay, so we use this to describe our data. So not only do we have common things, like in the column graph, we also have the shape of the data. Okay. A third thing we can use to describe things is a modal class. A modal, fancy word for mode. Okay, just the most commonly occurring value or interval. So the peas in the pod, there were 6. That was the most common thing. That would be our modal class. And the opposite of that would be an outlier, the exception to the pattern. Things that are way different from everything else. Okay, they lie far outside the majority of the data. So take a look at this graph here. Okay, most of the data is between 2 and 9, yet we have this one single piece way up at 13. It would be an obvious outlier. If you go back to the peas just for a second, okay, I don't think there would be any outliers. Most of the data is pretty close to the majority. I would need something maybe at like, I don't know, 10, 12, 13, 14, maybe 15. There's 15 peas in the pod. That would be really weird compared to the rest of this data. Right? The most highest after that would be 9. The majority is around 6, the modal class. Okay, so outliers are things that are far, far away. Okay, we're going to try one now. Okay, last example for this first lesson here. Okay, I want to, we have Arthur here, catching a train to school from a busy train station. Over the course of 30 days, he counts the number of people waiting at a train station when he arrives. Okay, we're going to construct a tally and frequency table for this data using these intervals. Okay, so where do we start? Well, part A here, we need intervals, we need our tally, and we need our frequencies. And they told us they want to start with 0 to 9, 10 to 19, 20 to 29, 30 to 39. You know you can stop when you reach the highest piece of data, so it's kind of helpful to find the highest piece of data. What do we look for here? I see a 44. I don't see anything higher than 44. So as soon as I get to there, I know I have the highest interval I need. So 40 to 49 will work. Okay, tallies. So we have to go through each piece of data and figure out which category it goes in. So 17 fits in here, 25 in there, 32, 19, 45, 30, 22, 15, 38, 8, 21, 29, 37, 25, 42, 35, 19, 31, 26, 7, 22, 11, 27, 44, 24, 22, 32, 18, 40, and 29. Okay, so our frequencies, we add them up. We have 2 here, 6 here, 11, 7, and 4. Okay, there we go. There's our frequency table. Part B, I want to construct a column graph for this. Okay, so using our rulers. Okay, so we're going to make a graph now. So using your ruler, to use rulers, kind of important, make our graphs here. We're going to our values across the bottom, our frequencies up the side. So this will be my time. Actually, sorry, it wasn't time, was it? What was this? This was number of people. Number of people. Fix that. And this was our frequency on this side. Okay, and we need across the bottom the intervals that were in our table. So we had 5 of them. Okay, so we're going to make 5 intervals across the bottom. You can decide how you want to make them. So 1, 2, 3, 4, 5. And our interval values that were from our table should go across the bottom here. So 0. And you can put 0 and 9 in between if you want to, or you can put 10 on this one, 20, 30, 40, 50. Okay. And up the side, we need to go as high as 11. So picking some sort of scale along the side there. Sorry guys. Scale. I can go by 1s. 2, 3, 4, 5, 6, 8, 9. Oh, nope, won't quite fit there. A little smaller than that. Okay, let's go by 2. It's 2, 4, 6, 8, 10, 12. That should work. Okay, now we need to graph our things here. Okay, so 0 to 9 there was 2. Now, because it's 0 to 9, my bar is not going to hit the 10 line. So I'm going to put some intervals in here. 2, 4, 6, 8, 10, 12. Okay, 0 to 2. So 9 would be right about here, right? So I'm going to go up. There's my 9. There's going to be a little gap between each bar. So 10 to 19, there should be 6. So 10, 19 should be 6. The bars don't quite touch. Okay. 20 to 29, there should be 11. So 20 to 29 should be 11. And then 30 to 39 should be 7. 30 to 39. And again, you should be using rulers for this. Unfortunately, I can only make short videos with this, so I'm going to run out of time if I don't go faster. And then we have 4 for the last one. Okay, and there's our intervals. We can then answer our questions fairly quickly. On how many days were there less than 10 people? Well, there was 2 of those. On what percentage of days were there at least 30 people? That would be 11 out of our total. We could add up our frequencies there. So 8, 19, 26, 30. So 11 out of 30 and turn that into a percentage. Okay, how would you describe this data? We're looking like this. Okay, I would call that fairly symmetrical. Okay, it might have a slight skew to it, but I would say that one's pretty symmetrical. It's almost exactly in the middle. What's the modal class? The most common? That would be 20 to 29. And are there any values we may consider outliers? Well, since they're all pretty close together, we'd say no. Okay, and there's the end of the first lesson.